I'm here. Eldritch, congrats on the first. Switch to a game trick to me. Leaderboard is still the same? Is there an issue with it? Something's very, very wrong here. Leaderboard is still the same. 37 minus 10 is 27. 27 minus 10 is 17. Wait, what? Five months ago. I think it's been saving, like keeping its progress, but oh, it is going by tens. Yeah, it's like 37, 27, 17. I assume there's a coincidence. As far as I know, it's working okay. It was 32 minus 10 is 23, 23 minus 10 is 13. Really? I haven't been doing that command often enough. I'll have to keep testing it when like other people get first, I guess. Or it's just the Eldritch magic. Oh, I didn't. Oh no, I didn't. Get my YouTube chat in my OBS doc. Uh, Good thing no one is chatting on YouTube yet, because I would have missed it. There we go. Okay. Reality break. I guess I'm not sure. So today we actually do have a question waiting for us in the Discord. It's stats though, which is unfortunate, but there's been a weird lack of stats for like at least 6 months, and so I don't mind trying to remember how this stuff works again. We're back to Eldritch's newsletter today. Hell yeah. Today's episode we have a punchline that is enough to give up your boking carrier? That part I don't know, but I'm excited. Hey, Gianluca. Boxing. Oh, okay. Oh, boxing career. I get it. Yeah. What is this person asking? Random samples, just stats, frowny face. All right, let's see if we can figure out what's happening here. Population, convenience sample. Okay, well, these are the... Okay, talking about sampling methods. And simple random selection, I think, is SRS, and that's usually what you want. First writer wants to take a grammar lesson. I mean, I only speak one language, so I can't judge here. Simple random sample, label individuals, assign numbers, write names on slips of paper, randomize random number generator or names in a hat, shuffle, and select. Assign a local bit business says, rate us 5 stars on Google and get a $10 gift card. Store manager uses ratings to learn how people community feel about the business. What type of sample did the manager obtain? I'm curious if this person... We'll just go through and answer these, but I'm curious if the person has a question on a specific part. This is voluntary response, but it's also rigged. It's our first joke from Gabriel Dinotorix or Dinotorix. What is the most meaningless and inefficient math aspect's name? What is it? I guess mass equals E squared. Saying me in short. Oh, meat. Okay. Um, hey, syntax error. So this seems biased because A, it's voluntary response, and B, you have to leave a 5-star rating specifically. So those, and I was about to explain that in two separate things, but I think I just had a way to say it in one phrase, and now I can't. Now I forgot it. It's biased because only people only people who had a good experience. Oh. Will leave. Oh my god, dude. I can't write. In review? Yeah, just in time for Eldritch's, stand-up comedy routine. Let's move our crowd to the microphone and get jokes. Yeah, our microphone to the crowd, rather. I have a chair joke that will 100% make you laugh, but then I realize who chairs. Oh no. Hey Hargy, there's no math in Daisy. There's math in Daisy if you're coding it. Or you could work out like what angle of elevation you should hold your gun at to hit your shot, Euler-Lagrange equation on a multivariable function. I feel like someone's asked me that like last week, and I looked it up and I have no idea what it was doing. So I don't. I feel like there are people around in chat who knew what to do with it, but I don't think I know. That's why he sucked the training. Yeah, Harky. Unironically, yeah. Hey Mateo, can you explain theory? What type of theory? Range finds that 92% of customers rate the business with 5 stars. Is 92% likely to be greater than or less than the percent of all people in the community truly believe the business deserves 5 stars? Actually, you know what? I guess I should. Smart enough for this. All right, Hargy. Well, thank you for saying hi. What is that emote? I need to see it bigger. Oh, it's a cow with a heart. I didn't recognize it at first. Aw. See you later. Okay, so maybe I'd rather say it's voluntary. Fuck it. People will only leave 5 stars, 5-star reviews. There we go. Trying to derive the equation for the length between 2 points on a ball. Oh. I feel like that came up during Penn Center's like complex variables course. I don't know if it was between 2 points on a ball though. But with the Riemann sphere, I thought they were doing something like that at some point. And it wasn't so bad using vectors. Or like a parameterized equation of a line. What do you call a crushed angle? What is that? Some advice on what mod you should try to prove a Diophantine equation doesn't have a solution. Oh, it's been so long since I've done anything with Diophantine equations. I'm sorry, Mateo. I don't think I have good advice for that. A rectangle? Oh my god, like it's been wrecked. Ugh. 92% likely to be greater than less than percent of people who truly believe. Well, greater than. Right now I'm just kind of like writing down my thoughts on each question, but this person posted in the Discord and I'm going to get back to them, not give them the answer like this directly, I think, unless they happen to be here and they get the answer directly, but how they feel. So then the manager decides to serve the next 10 customers to make a purchase. That seemed like a convenient sample. But it's still going to be biased because we don't only have one joke about angles. We have an extra one under it. What's the best way to flirt with a math teacher? What's that? So this is still potentially biased because people come into the store. Probably I shouldn't say probably, I should say are more likely to like the store. Can lead to bias. Use a cute angle. Oh, use a cute angle. So our worst joke, you rather be El Khazari? I don't know who that is. How can the manager avoid the bias described in question 2? I guess ask people passing by the street how they feel about it. That one's a little bit weird though. So it feels like time ran out. Let's see our new part. Jokes from you. I don't know if I have jokes. To break out a book. Oh, someone hop in here. Hey, Gianluca. Okay. Hey, Da. All right, so for this person, stop sending racist jokes. Oh no. I hope no one's actually sending you a racist joke. I assume that's a joke. Hey, Speed Cuber. Jokes in our new Gmail. Oh, good. The first question looks like voluntary response, and the second one looks like convenience sample. If the goal is to get the true feelings of members of the community, not just customers of the store, then each of the approaches they outline have issues. Do you what do you think they could be? Hey, Phobos. Okay. Speakeeper, we were just working on a stats question that was posted in the Discord. I worked out how I think of it, but I want to try and like get this person to start thinking about like the issues with the sampling methods they propose on their own. So I just kind of gave them what I thought for the sampling methods. Like I basically said what I think the answer is for part A of each like 1 and 2 questions, but the actual like why it could be biased is. I'm gonna see if I can get them to say it. Drama de Julia, and her joke is why did the math professor divide sine by tan? Why is that? Oh, just cause I didn't unmute. So that's not a bad one. I'm gonna be honest. Please, please, please. Okay, for this stupid bead, I've been working on this one for so long. I'm tearing down the approach that I use, and I'm gonna try and use a different construction. Oh yeah. What's your question, Da? I don't get why you wrote please in 73 times. Okay, so I did like glance at the answer key. No. I was just wondering if I did do it right at one point, but I did not. This is not even close to a circle. That's a very sad circle. Okay, so I think the book's answer measured theta kind of how you would normally, like horizontally. Don does math? Oh no. It's a beautiful circle. Thank you, Speedcuber. Oh, I don't have a math joke. Do I even have a joke in general? Am I that boring? Dude, I don't know. I'm on the spot now. It's in math discussion? Okay, I'll take a look. Hey, Jackson Ford. I'm sorry, Eldritch. I'm coming up dry right now. I'm not built to perform. All right, it's the question from Da here. Jackson, you can put it right there in chat, or you can put it in my Discord. Whatever's easier for you. Okay. A spherical snowball melts in such a way that its diameter decreases at a rate of 0.4 centimeters per minute. At what rate does the volume of the snowball decrease when its diameter is 8 centimeters? Okay, so this is a related rates problem. And I've messed this up before, so just before I say the wrong thing, let's look at the volume of a sphere. It's 4/3 pi r cubed, right? Okay, I've been known to say that it's 4 pi r cubed, and that's not right. Because I get it, because that's it. The surface area is 4 pi r squared. So the volume of a sphere is 4/3 pi r cubed. And basically what we're going to do is we're going to take the derivative of each side with respect to r, the radius, because that's what's changing here. So dv dr is equal to 4 pi r squared. And I'm sorry, we're taking the derivative with respect to time, aren't we? Yeah, we're taking the derivative with respect to time. And I should actually, before I even think about taking derivative, I should have been more specific. So the radius is changing with time. So r is a function of time. It's actually r of t. And since v depends on r, v is also a function of time. So we could also write this as v of t equals 4/3 pi r of t cubed. And we're going to take the derivative of this thing with respect to time. So dv dt is equal to 4/3 pi times, now power roll in the 3 times r of t squared. And then because of chain rule, we need a dr by dt here. All right, Eldritch. It's very comforting, you know, to have an Eldritch monster just watching me sleep. I'll see you around, though. This is the equation that we really need here. Let me clean it up a bit and cancel the 3 with the 3. So we get 4 pi r, oh god, of t squared dr dt. So they want to know what rate is the volume decreasing when the diameter is 8. That means the radius is 4. So we want to know what dv dt is. 4 pi is still the same. If the diameter is 8, the radius is 4 squared. And then the rate, they're saying it's decreasing at a rate of 0.4 centimeters. So I'm going to put negative 0.4. And now we just solve this. So dv dt, that's annoying. Who knows what 4 to the power of 4 is? Well, we know it's the same thing as 2 to the 8, which is 128 is too low, isn't it? Maybe it's not. 256, yeah, that's better. And then it's 0.4 right there, so I'm going to say minus 25.6. You know, I'm going to fact check that. The more I look at it, the less confident I feel now. I think that's right, but sounds good, Jackson. You'll be right after this. 4 times 4 squared times 0.4 to 25.6. All right, I'm good. And so I'd say it's that means that it's decreasing. Did they say to round it? The answer is a positive number. So I was careful with my signs, but since we're saying the word decreasing, we can put a positive number after that at a rate of positive 25.6 pi cubic centimeters per minute, I'd say is the answer here. Does that make sense, Da? No, no worries. The goat, show why the rotation matrices form a subgroup SO2 are diffeomorphic to the circle. I'm sorry, I don't think I know how to do that. The mechanism in figure Q1 has two links. One link ABC. It's my favorite pizza waiter. There you are, Jed. Hey. Link ABC with a hinge at A hinge at B with vertical downwards force of 50 newtons applied at point C. Oh god, we got torque involved here. Yeah, that pizza broth was probably delicious. Oh, I love onions. I'm not feeling confident that I can do this one. I'll try. Okay, so the question is basically asking if we're pushing with the 50 newton force down on point C, what's the horizontal force that D is exerting on block E? Oh god. Uh I'm sorry, I don't think I know how to even start this. I could try to Google the question and find the answer. Uh, I, I don't even know. Like, yeah, I'm sorry. far does that get us? Oh god, this is an actual textbook. I wonder if if it has an answer key, maybe we can actually nothing. It's two links. Hinge at. Really? Okay, it doesn't seem to be in this book. Yeah, sorry. Someone, if you keep it up there in the Discord, someone might take a look at it and answer it. But that's something that's beyond my physics knowledge right now, at least. I'd love to learn how to do it. Crudo Hori, thank you for the follow. You got 12.8 pi for your question. Hey, Crudo Hori, how's it going? Sorry if I'm saying that wrong. I'm doing good too, thanks for asking. Did you get these same numbers here as me, or did you put a different number there, duh? Oh, wait, the diameter is decreasing. Okay, I misread the question. They're saying the diameter is decreasing at that rate. So I assume the radius is decreasing at half the rate? Is that what we have to do? And is that where the 12.8 comes from? What if we did this problem in terms of diameter? How does the formula look? Yeah, let me try with the diameter. You're probably just right. dt. Not the prettiest, thing I've written, but and what is this? Is that 128? We have two to the minus one, 2 to the 6, 2 squared times 10 to the minus 1. with a negative. Negative 2 to the 7 pi 10 to the minus 1. 2 to the 7 is 128. Yeah, you're right, Da. I made a mistake there. Good catch on that. You've got your water bottle here, don't mind me. Okay. I think we're caught up on questions, so let's go back to the study one. The hypotenuse there is r. That distance there is h. Not necessarily. Not for all. Well, I mean, it is, but we need to consider different kinds of theta as well. So, like, this would lead me to believe that h is equal to r cosine theta. But if theta is over here, and we have this angle, like now theta is this. Hey Joel, you have to integrate 4x plus 1 over root x squared plus 4x minus 12. All right. We probably have to complete the square and do a trig sub, unfortunately. Is there a trick though? Can we avoid this somehow? Like just a straight up u sub with a denominator would nearly cancel the numerator, but not quite. Let me just go put my mug away and we'll get cracking on this. Okay. Yeah, unfortunately, I don't see a better idea than to complete the square here, which is kind of like the long and hard way, but I don't see a trick. Try manipulating the derivatives be try to manipulate the numerators be the derivative of the root. I mean, we can consider that more. I don't immediately see a way to do that because the factors are just off. Because like this constant term is twice the coefficient of the other term, and that same relationship just is not true over here. So I don't know how we can Like, we can plug into Wolfram Alpha and see if it finds a trick like that, but I can't find a trick like that. Yeah, we're probably not getting, if it looks like that, I don't imagine. Yeah, they're completing the square. Yeah, I love it if this U sub did work. I don't think it does though. Alistair, question from A-level further maths edXL 2023. I don't know what the edXL part is. If you have a specific question, I can try to take a look, but those questions are pretty tough. Hey Rapture, in Levo, f of x equals x minus 1 over x minus 2 put in the standard form of hyperbola. I don't know exactly how you do that. I'm working on Joel's question first, but I can try to take a look at it after. I don't see exactly what manipulation you should do. Let me write that down. I'm gonna have to come back to it later though. Is that even a hyperbola? That just looks like a rational function. Maybe it is. What website? I'm not trying to write down a website. I'm just doing I'm just writing a question that was asked in the YouTube chat. Got some fun integration questions. Oh, I mean, my emphasis is like doing the homework help thing. So, and we got some people who are asking for help. So that's always my priority, Alistair. Okay, duh. You're gonna be third in line though. So yeah, Joel, for this one, I don't think we have a time-saving trick, unfortunately. We have to complete the square here. And so the thing that'll complete our square should be 4. Plus 4 minus 12. X plus 2 squared minus 16 dx. Am I going trick-or-treating? No. Oh, I'm sorry, Rapture. I misinterpreted your question. This is a program, not a website. It's called Journal with an X. That's what I use to write things down on. Okay, and then here we're going to do we're gonna do a U sub here. We're gonna have to do a second substitution later on, but that's just life. I just want to get rid of the x plus 2 there. Let me go down the line. So if u is x plus 2, then x is u minus 2, and that'll be helpful for that x right there. So 4u minus 2 plus 1 over root u squared plus 16 du. And now these are normally easier if we factor the 16 out. So I'm going to do that. And I'm also going to multiply out the numerator. 4u minus 7 over root 16, 1 over 16 u squared plus 1. And I don't have a big idea with that. I just know that oftentimes these are easier if you have the 1 there. The 16 can come outside the square root. And I'm going to bring it outside the integral. So it'll be 1/4 because the 16 gets square rooted. And instead of writing that as 1/16 u squared, I can write it as a 4th u in parentheses squared du. Explained by, oh, okay, by Gidgeon. Never mind. Okay. And so this should look like a trig identity. If we know that sine squared plus cosine squared is 1, we can divide everything through by cosine to get tan squared plus 1 is secant squared. So I want to make this 1/4 u look like a tangent. So I have this identity here. So I'm going to take I'm going to set 1/4 u equal to tangent v. And so that means u is, we can just keep it like that, who cares? No, I won't. I'm going to do u is equal to 4 tan v. That means du is 4 secant squared v dv. Ooh, do I need to split this integral up before I do this? Maybe not. Let's just do this up. I might need to back up a step and split this up into 2 different fractions. But let's just try this up and see where it lands. Hey, Dipion. Okay, so u is equal to 4 tangent v. So we're get 16 tan v minus 7 over root tan squared v plus 1 times 4 secant squared v dv. Okay, so let's apply the identity to that tangent squared plus 1. That's the entire point of doing this. And ooh, the 4 here and the 1/4 out there can cancel. What to eat for dinner? I don't know. What do you have? So then secant can cancel with one of those secants. So we get 16 tan v secant v minus 7 secant v dv. Okay. This is just secant. The integral of secant, though, I think is something weird with ln's. You have nothing, so you can buy anything. Oh! I mean, I just ate some ramen, and that was pretty good, so that's what I'm going to recommend. The integral of ln... I'm sorry, the integral of secant is annoying. What's the trick for it? Do you do integration by parts? Oh, you do that. Yeah, Wolfram Alpha's doing a weird thing, but I know that's what the result should be, duh. I just... don't want to just like use it though. You solved it? Oh, nice, Jackson. I know about integral calculator. I'm just used to using Wilhelm alpha, I guess. So this first one, that's just secant. 16 secant v minus 7 integral. So we multiply, how you integrate this the easy way, I think there's a hard way that I've done before, but the easy way is to multiply it by tangent plus secant over itself. And then you do a sub u equals tangent plus secant. I'm going to work out this integral separately in green because I don't want to bother writing the entire rest of the problem for this. So when you before I do the u sub, let's just multiply it into one fraction. Oh, no. Okay, and then it won't be a u sub, I guess. We've already used u. I guess I'll do a t sub? No, t is a... A y sub. Why not? Y equals secant v plus tangent v. dy is secant v tan v. Tangent becomes secant squared. And that's the trick because that exactly matches the numerator. So, and the denominator is just u, or y. So 1 over y dy, integrate that to get ln y, unsub to get ln secant v plus tan v. That's how you show that one. Keep shifting these down. All right, back to the work in black. 16 secant v minus 7 ln secant v plus tan v plus c, and now the task is to unsub. So v, if u is, or I guess if 1/4 u is tangent v, then v is arctan 1/4 u. So we'll start with that. Plus tangent arctan 1/4 u plus c. Okay, and this is where things get funky and you have to do some right triangle business. Yeah, it is, Alistair. Okay, so we know that arctan 1/4 u, I'm going to write as u over 4, is equal to some angle theta. So I'm going to draw a generic right triangle, label this angle as theta. And so arctan is opposite over adjacent. So opposite is u, adjacent is 4. Pythagorean theorem tells us the hypotenuse is root u squared plus 4. Secant of that theta angle is hypotenuse over adjacent. Multiply both sides by 0. There you go. So we get 16. This secant is root u squared over 4 plus 4 over 4. Oh, sorry, that's 16. Because it's 4 squared. Minus 7 ln. This secant is the same exact thing. And then tangent of arctan, those are inverse functions, so they undo each other. No right triangle needed. Okay, now what was u? U is x plus 2. So we're nearly there. All right, so the 16 and the 4 can partially cancel. Wasn't that a minus 16 in the original problem? Should I be worried about that? Wolfram Alpha, should I be worried? I should be worried. It's supposed to be a minus sign inside there. Why? Hey, Gistmeist, we got a queue going. I might skip through the queue if people don't have to be in chat at the moment when I ask them, but I'm working on this question above, and then these two people are ahead of you. But you certainly can. Where did I go wrong here? Oh my god, I went wrong so early in the problem. That's a minus sign right there. Oh, this is disgusting. Oh no. Oh, this is garbage. We can just delete all this. That changes the entire... Oh my god, I just randomly changed a minus to a plus. Unbelievable. Yeah. It sure did ruin it. Okay. Well... when we have something minus 1 squared, is that actually a cotangent situation? That's an uncommon one to get. I think Paul has a little chart. Somewhere. It's a secant sub. Interesting. Oh, so you never do like cotangent or cosecant, apparently. Okay. All right. We know that tan squared plus 1 is secant squared, and we can rewrite that to be tan squared equals secant squared minus 1. So we want this 1/4 u to look like secant. Okay. 1/4 u equals secant v. That means u equals 4 secant v. du is 4 secant v tan v dv. Okay. What do we get now? We're gonna keep my screams on the inside. I feel like I'm doing a good job of it. 16 secant v minus 7 over root secant v squared minus 1 times 1 over 4 secant v tan v. Oh, TV dinner. How's it going, dude? Thanks for coming by. Firens? I mean, you can have firens too. Yeah, not only is it complicated, I got like my work was all the way like down here, and I realized I made a mistake and I have to back all the way up. I randomly made a minus sign there into a plus sign, and it just threw everything off. But yeah, it's an annoying type of problem, but they're good to know how to do. So I use a pencil. Yeah. I'm gonna bring that 4 out front. So 1 over 16. Wow, isn't this so much? This feels really difficult now. That becomes tangent. So we get secant v tangent squared v dv? What do we do with that monstrosity? ChatGPT actually got your question right? Is applying the gamma function? Oh, okay. I'm glad that you got help then, because I don't know much about the gamma function. It's impressive that ChatGPT actually got a question right, though. I don't really trust it for much of anything. What do we do with this integral? I think we split it up into two. Like 1 over 16 secant v over secant v tan squared v dv plus 1 over 16 minus 7 over secant v tan squared v. What is cotangent? Trig derivatives. Yes, for procedure more than result. Okay. Cotangent becomes cosecant squared. That's right. Okay. Okay, well, the first integral. The 16s can cancel. We have to integrate cotangent squared. That one's not so bad though, I think. This one though, we can write it as cosine v over tangent squared. Is that helpful? Tangent is sine over cosine. Can we? Yeah. We can do this. Cotangent, I'm gonna rewrite. How would we get to cotangent from this identity? We divide everything through by sine. 1 plus cotangent squared equals cosecant squared. So cotangent squared is cosecant squared v minus 1 dv, and this should be cotangent. Final answer, I'll show it for a second here according to Wolfram. instead of arctane, it's gonna be something with LNs, but I'm looking for something that looks like this. Okay. 7/16. This will be cosine cubed over sine squared. Oh no, that's not as clean as I thought. Bruh. How do we fuck with this to make it work? Like, okay, let's the integral on the left is easier. Cosecant squared will integrate to negative cotangent squared, or just negative cotangent. Do we want to do cosine v 1 minus sine squared v over sine squared v dv, and then we can take, like, we'll do a y sub again, who cares? Y equals sine v cosine v dv. Hey Anand, I'm doing okay. How about you? I just made a major mistake on this problem, but before this, I saw the new Venom movie with friends, and I got some ramen, so that was a nice time. Not you. Why? This I think we know how to do. Minus cotangent v minus 7/16. It was alright. Nothing like crazy good, but it wasn't bad. Which, I mean, I've seen the first Venom, and then I just saw this most recent Venom. They were like about the same quality as far as I remember. How does... Dude, why is everything negative? I have a negative sign on every single thing here. That makes me feel nervous. Should I just hope for the best and keep it going? I think I'm gonna hope for the best and keep it going. If I did make a mistake, I don't see it yet. This is a beast of a problem. Okay, so let's get rid of the y's. Oh my god, I just included a y when there wasn't one. Okay. Minus, oh wait, this will turn positive at least. So y is sine. Okay, I don't want to write sine to the negative one, so I'm going to write cosecant v plus 7/16 sine v. Okay. Inception? Yeah, I have. That's a good movie. I feel like I need to look up a video on Inception, though, still. Because I feel like there's a lot of it that I'm missing. If 1/4 u is secant v, 1/4 u is secant v, then v is arc secant 1/4 u. Taking integrals next semester, you're making me stress. A lot of people, there's a lot of enthusiasm for integrating things. There's actually like integral competition, so you might find that you really enjoy it. I enjoy some integrals, but there's gonna be some kind of gnarly tricks that you have to learn, unfortunately. This isn't right. This can't be right. Because, well, unless this u, well, what is u again? No, u is x plus 2. This can't be right. This lone arcsecant here is it's wrong. I'm doing this wrong again. Oh, fucking hell. Satisfying. Oh, like a Feynman's technique, Territar? Yeah, that is pretty cool. All right, I think we're going to take Joseph's suggestion here. We're going to break down and use the integral calculator. I can talk, don't worry. Because I shouldn't be spending this long on one question when there's a queue here. What was the question? 4x plus 1. 4x plus 1 over square root something. X squared plus 4x minus 12. X squared plus 4x minus 12 dx. Ugh. That probably agrees with Wolfram. I don't know what the definition of arc hyperbolic tangent is, but... Oh my god, Joel was right. I didn't see the trick. You still have to do a lot of painful stuff. Ah, I forgot you can do this. Like, specifically this step here. Joel, are you still here? Okay. I let's see if I can get through this. That there should be a way to make what I was doing work, but I'm just doing it the hard way, I guess. You are still here? All right. So I need to apologize because you were right with what you were saying with looking for the cancellation. Dude, now we get to delete even further up in my work. Don't know if you do physics. Oh, about pulleys? Nah, I'm sorry, Marshall. I'm trying to learn more about physics, but I'm pretty terrible at it. Okay. Thank you for your patience, Joel, and like as I try to do this integral mostly blind. But you're right. There is a way to manipulate this numerator to get this cancellation with the u sub. We have to make it 4x plus 8 because of what I said with like 4 is twice of 2. But we can't just magically make this 8. We have to compensate it to make sure it still equals that 1 there. So I'm going to subtract off a 7. Root x squared plus 4x minus 12 dx. And now you split up into two separate integrals. So 4x plus 8 over root x squared plus 4x minus 12 minus 7 over root x squared plus 4x minus 12 dx. Oh yeah, happy oh, I can't talk today, dude. Happy Halloween to you too, Joseph. I can't talk ever. Well, what am I saying? We'll apply the u sub into that first integral. So 4x plus 8 is twice of 2x plus 4, so that becomes a 2 on top. 2 over root u du. Hey Cook. How's it going? Now, okay, let's verify with integral calculator, but by the way, I should drop the link to this site, because it is actually a really good website. I just am Maurice to Wolfram Alpha. For this piece of the integral, you do complete the square. They just say that's a standard integral. Okay, but it will be a trig sub. Okay, so the complete the square that we got was x plus 2 squared minus 16 dx. Don't magically change that minus 16 to plus 16. Whatever I do. Okay, and let's do one more step here before I do side work. Let's integrate that. We get, what do we get? We get 4 root u minus 7 1 over root x plus 2 squared minus 16 dx. Look, I have 2 people who have asked me a question that are waiting to go after this one. If you want to, I can definitely do it on stream at some point today, and I can like message you in Discord or at you in chat when I do start it if you want. I'll even like just put you in queue there, so I don't forget. Yeah, I haven't even looked at it, but if you don't mind me showing on stream, I'll absolutely take a look at it on stream. Okay, so now let's do side work in green for that integral. On stream? Okay. U equals x plus 2 to start with. Du is dx. So we're gonna get 1 over root u squared minus 16 du. Factor the 16 out. We get 1/4 1 over root 1/4 u. Oh my god, I'm going too fast. I'm writing way too sloppy. Minus 1 du. Oh, you transferred the problem to tonight? Oh, I see. Yeah, this is where we need our trig. So this is still secant, I think, unfortunately. We're gonna say the thing we have, 1/4 u, is secant v. So u is 4 secant v. Du is 4 secant v tan v dv. 1/4 integral 1 over, so that becomes just tangent when the dust clears, times 4 secant v tan v. I think I might have done it. That's probably, oh, I made that 1 over the last time, and that was probably what I did wrong. So what do we get here? 1/4 integral. Actually, the 4's just cancel, don't they? So we just get the integral of secant. And I did work that out, right? You multiply it by... Ugh. Yeah. You multiply it by tangent plus secant. Not squared. dv, you take y equals to secant v plus tan v. dy is... What am I writing down there? Just ignore those squiggles. Oh my god. So you just get 1 over y dy is the moral of the story. And that's ln y, and that is ln secant v plus tan v. And that is v is arc secant u over 4. So secant of arc secant is just going to be u over 4. Tangent of arc secant needs a right triangle. All right, right triangle, theta, opposite. So arc secant is equal to hypotenuse over adjacent, because it's 1 over cosine. So hypotenuse is u, adjacent is 4. So the remaining side is u squared minus 16. That should bring us to the promised land. So what we get for the end of the green work, not the end, but close to the end. So we want tangent of this triangle now, so that piece divided by that piece. And then u is x plus 2. Okay. End of the green work. So going back up to the black work there, we have 4 root. That's not, is that still not right? There wasn't a 4 and root x plus 2, was there? Oh, what? Don't thank me yet, Joel. Did I say to do the first part of this wrong? Going trick-or-treating in like 15 minutes. Oh, okay, duh. Sounds good. Sorry, this problem took longer than I thought it would. Yeah, if you type back in Discord though, I'll respond to you. How am I still doing something wrong? This is ridiculous. Oh, I forgot what my U is. No. This is a different U. I'm using U in 2 different ways. It's because this U is that U. Oh my god. I'm sorry, I'm using my mouse, so it looks terrible. I'm just using... I use U twice, and that was port form. X squared plus 4x minus 12. Minus 7 times whatever I got from the black, or from the green work, which is ln x plus 2. We can even group that. Root x squared plus 4x minus 12 over 4 plus c. And there's one more thing that we can do. You don't have to do it. This is technically the right answer right here. But we can use a log identity just to make it look a little simpler. X squared plus 4x minus 12 minus 7 ln. So when you have division inside a log, you can split it up into a log minus a log. You don't have to do this. Like, you could just stop at the last step and you're still correct. But we could also say this. So I took this 4, I put it into its own log that's subtracted off. And this is just a constant. And a constant plus a constant, we can just call it another constant. Okay. Hoo-hoo, hey! How are you? Okay, we finally got to the end of this problem. Hallelujah. Thank you for the question, Joel. I'm doing good too. I was hanging out with my friends this morning. We saw the new Venom movie and we got some ramen. It was a nice time. Oh, Devin, I'm so sorry. You typed and I completely skipped over that. I'm not very good at math. Can you explain in 10 seconds what an integral is? That big sign. Yeah, I'm so sorry that I missed your first message there. Did I ever try a pumpkin latte? I don't think I've actually gone out and gotten one. I mean, honestly, probably it sounds good, but I usually just drink a black coffee. Hey, travel vlogs and science. Uh, yeah, Devin. So yeah, it's called an integral. It's like a stretched out S. The 10-second explanation is that you learn about it in calculus, and it gives you the area under the curve. So if you have a like whatever function you want, like it could look like that, you can integrate from say x equals 1 to x equals 5, and you get the area underneath that. So let's say you get like the area of like, you know the formula for the area of like a rectangle, a triangle. This lets you get the area for like, a curvy shape. You always drink weird stuff? Yeah, fair enough. So yeah, definitely. I think it's a 10-second explanation of what an integral is, at least. How you actually compute it, it can be pretty challenging, but that's the interpretation. Okay. Lebo, are you still here? I wouldn't blame you if you're not. Yeah, so the big ideas in calculus are derivatives and integrals, and integrals are the thing that you learn second. They're kind of like derivatives and integrals are kind of opposites of each other. In my travel vlogs and science, I am normally live on YouTube on Tuesday, Thursday, and Saturday. Or if you haven't left for trick-or-treating yet, I can try to speed run your question before you have to leave. All right, that's a pretty quick one. Time? I normally start 2 hours and 20 minutes ago, or at 1 Pacific time. I feel like, okay, so a while ago, this person asked me to write this function in the standard form of hyperbola, but is this even hyperbola? I need to graph it. X minus 1 over x minus 2. I feel like it's not. X minus 1. Is a pumpkin latte weird? Oh, I guess that's hyperbola. It's just like, I've never thought of those as hyperbolas. I thought they were different. It's like a tilted hyperbolic. I don't know if that does it even count. I feel like it's just not. I feel like it's something else. I haven't seen Lebo type in chat, and I feel like I don't understand the question anyway, so I might just sneakily move on. Yeah, I don't know what I would do with that as locus of points. All right, Devin. See you around. Thanks for hanging out. Any rotated hyperbola is still hyperbola? Oh. I mean, but is it the right shape? Like that's what I wasn't sure of. Or that's what I assumed, like, it's probably not. Because I don't think you get, like, an x squared and a y squared. Okay, we can dig into it a bit, even though the person isn't here, but... Dawes said they would try their problem on their own. I haven't seen them type, so they probably left to go trick-or-treating. It's worth... Oh god, that sounds terrible, though. Memorizing the geometric definition of all conic sections. Because, like, this is the manipulation I was thinking of doing. But then what do you do with this? I don't really get it. Oh, okay. Yeah, it's like to rewrite that in the same form of hyperbola. And I've never considered that a hyperbola before, but I don't know. It is kind of the right looking shape, but I don't know how you possibly manipulate it to look like a hyperbola. Like, I guess you could square each side or something, but that, like, this x minus 2 is stuck in the denominator. So I don't quite know what you do with that. I think that means we just move on to your question then, Cook. So I'm going to bring it into the page here. I'll clear up some space and then I'll bring it onto the page. Okay. Oh god, I forgot this thing doesn't play nice with images that go off the page. Okay, a hollowed out cylindrical resistor green is formed from a material resistivity rho, as shown below. The resistor has axial length L, inner radius L. Oh, okay, so they're the same length. And outer radius L plus A. Okay. Calculate the axial resistance R sub A between the flat faces perpendicular to the axis of the resistor. So this is one that, like, I think that's like the type of question that I think the Morin textbook didn't go much into, but we looked at one, like, you showed us one like this. I remember with, like, a tube that's wider at one end than the other. And, like, I didn't even know, but you can set up an integral for resistance. Can I find the notes from that? He covers the main formula? Oh, okay, let me see if I can find it, because I'm feeling pretty rusty on this. It would have been chapter 4. I wonder if it'd be in the summary. I don't know if it made it in there. Second dot? Oh. Right. But we need to see how that's constructed, right? Because that's just the result for a wire. Unless that's applicable here. And maybe it is. It's just a wire with a hole in the middle. It is applicable. Okay. So is it rho L over A? So we need to find, excuse me. Okay. Maybe I'm just gonna come down here. So we need to find the area in terms of L here. So that distance is L. That distance, I think it was just capital A? No, lowercase a. So A is equal to pi L, oh my god, L plus A squared minus L squared, which is pi 2L A plus A squared. LA feels weird to me. I'm in Northern California. AL. Do I do inertia? I'm pretty bad with. I basically. I'm terrible with all of mechanics, Marshall, and I'm barely passable at E and M, I would say. I'm trying to get better at mechanics, but I'm just not good. Yeah, like for like my like things that I can help with, like the most, like for sure, like a calculus class or something like that, for like an actual like math class. For physics, I'd love to learn more about it, but my physics is terrible in general. Okay, so I assume this is what I want for part A. Looks good. Okay. So what's the to calculate the radial distance r between the inner r equals L and the outer r equals L plus A radial walls? Okay, so instead of going from that flat face to this flat face, we're going from the inside face to the outside face. And reason as follows. Flowing from the inner wall to the outer wall, electric current encounters a transverse length A and cross-sectional area 2 pi L squared. So R sub R is equal to rho A over 2 pi L squared. Isn't... Well, if we need the... No, it's... So the reasoning is incorrect here because the cross-sectional area... That's just strange to me. The area of this ribbon increases the further out you go transversely. Oh, maybe I see. Oh, I know where the 2 pi L squared comes from now. But, yeah, because it's 2 pi L, the circumference, times the width L. I thought it was like area times 2, and that was like confusing, but the cross-sectional area increases as you travel transversely. I mean, I kind of have all my answers up top there. It's 2AL plus A squared. Oh, okay. And that's why there's nothing like varying when we're going horizontally. So that's why A was simpler. Applying your insights from B, use integral calculus, to calculate the radial resistance R sub R. Show that your resistance R sub R has dimensions of resistance. Okay. Well, R is equal to rho L over A. And we need to find a formula for A, I guess. Well, we already have a formula for A. If we treat A as a variable, I guess. Maybe we want to use X to differentiate it from the entire length A. Okay, so that's R. Sorry, that's an R. That's L. We're gonna look at a circle of width dx, I guess. I should make this a different color, but too late now. That entire length is x. So the area of this thing, of that ribbon, is the width x times the circumference of the circle. Sorry, no, the width is not, the width is L. Times the circumference of the circle, 2 pi x. Yes. And if x equals L, we do correctly get the student's mistaken result. Hey, $10. This is the problem that Cook messaged about, just as a heads up. Okay, and so a small change in area is equal to 2 pi L times a small change in x. I think we can claim that. It's time to help me with C. Yeah, so I'll scroll back up and show like what we've done so far. Oh, if you don't want to be spoiled on it, then look away, I guess. But they've gone through A and B. And so it feels like a similar vibe to that one problem that Cook showed us before, with the cylinder with one end wider than the other, I think it was. But yeah, of course, if you're just chilling, then no need to try it too, but I'm just working on part C right now. So this L, is that, what does that L represent? That's the length. That length is constant. Yeah, because the L in the numerator is this L up here, and that one isn't changing. So we can treat that one as a constant. So if we plug in our A, 2 pi, well, that's not good. Why is the dx in the denominator? Maybe I shouldn't sub it like that. Maybe I should figure out what dr equals in terms of dA. How does this work? Do I literally... Like, this makes me uncomfortable. But I don't know what else to do there. Oh, yeah, I mean, I see what I was doing wrong before with why the dx in the denominator, but... What? I guess what happens here if I just roll with it? When you slice up the resistor, what is infinitesimal? No, it's the width dx. Or it's, wait. Yeah, it's, Am I doing this right? It's like... It's the thickness of the ribbon that's infinitesimal. So I should plug in X first, and I was plugging in the wrong thing. Like, I should do that. The L's, I guess they cancel, but it might pop back in. So this still... not DA. Like that? Infinitesimal distance rho times infinitesimal transverse length. What? Hey, Tinnock. You can type it out there in chat, or you can put it in my Discord. Just as a warning, though, this one is gonna take me a minute that I'm working on right now. The transverse length is always L, though. Like, that transverse length. No, oh, wait. Oh, it's the wrong. Ah, I'm thinking about it wrong. Yeah, that L is no longer the transverse length. Ah. Fuck me. I was literally asking, I was like wondering to myself if this L is the same. I was like, oh yeah, it probably is, but no, it's not. I mean, I think I should have realized that, but dl equals dx. Yeah, okay, I was just wondering if I need to make a formula to represent that or not. I thought it'd be like I have to get a relationship between L and X, I guess, but I guess I don't. Hey, Waffle. I'm dressed as a nerd who streams math on the internet. That's my Halloween costume. No, I'm just, well, I just been in college. But, I mean, once in college at least. I don't, I haven't been very into dressing up for a long time, though. Okay. We know what A is with respect to X, and that's where the actual, integration comes in. This L we still need. Yeah, okay. I think we're ready to integrate. This is the 305th time you've dressed up this year. Yeah. It's a classic. What can I say? It truly fits for every holiday. Every day, not even a holiday. Gotta keep my streak. I don't need absolute value. This is physics. We don't care about absolute value here. Okay. I think that's my answer for part of the answer. That is my R sub R. We need to verify it as dimensions of resistance. There you go, Fembox. Join me in not caring. What are the units of resistivity? It's probably ohm time meter, right? Volt per ampere. No, that's an ohm. Gotta make a math nerd Halloween party to get y'all in spirit. Apparently, yeah. Won't choose measure. Oh wait, it is ohm meters. Okay. So we have ohm meters over meters dimensionless. Okay, so we do just get ohms. I don't know why I put an S on meters, but not an S on ohms, but that's how I'm doing it. Okay, so the units seem to check out. Okay, D. Suppose only for this part that A is much less than L. Okay, so it's a very thin ring. Use integral calculus. Oh, so the resistor becomes a thin ring geometry. Use the Taylor series approximation for ln 1 plus x is about x, valid for x much less than 1. Oh, so yeah, that's why we need that restriction. To approximate the radial resistance R sub R in this limit. Is your friend's reasoning redeemed in this limit? If so, why? Oh, this is a Simpson Wave 1995. Yeah, it's not bad. Over Arena 2016? Oh. This is just a random synthwave playlist that I tend to use on stream. I do like the music in it. But I normally listen to music with like lyrics, I guess, or like singing. There's some electronic music that I like though. I also usually listen to the music with screaming in it too, but okay, so in part D, that's not a D, that's a D. A is much less than L. R sub R is about rho over 2 pi L times A over L. Oh, it seems like it. That makes sense, I guess. Yeah. Okay. I guess I see what you're doing there. That infinitesimal thickness doesn't really matter for a ring that's thin enough. Two pi L squared. Yes, my friend. Dude, this person is not my friend. All my friends can calculate the resistivity due to a hollow ring, okay? No mistakes allowed. Yeah, I mean, that's probably the better way of phrasing it, but that's basically what I was thinking. Sounds good, Tinnock. I'll take a look when I can. We're getting to the ends of this question. Just two more parts. Is very little thickness to vary over, I guess. I don't know. If this resistor is constructed with L equals A and connected to a battery in the axial versus radial configurations, which configuration will heat the resistor faster? Ooh. Okay. So I guess we should look at what happens when L equals A. In both scenarios. So R sub A I guess we'll do everything in terms of L. Ugh. There it is right there. Rho L over pi 2L squared plus L squared. Is that it? Yeah. So that is rho over 3 pi L. My eyes don't deceive me. Think so? And then R sub R is rho over 2 pi L ln 2. And so now the task is to figure out how does 1/3 compare with ln 2 over 2. Well, I'm pretty sure it's like that. ln 2, is it like that? Yeah. No? Yeah. No. Yes? No. Yeah, 2 is less than e. It's probably a safe assumption that... Let's plug it into a calculator to be sure. But I'm pretty sure ln 2 over 2... Wait, I'm sorry, I have it backwards. The alligator's eating the bigger one. ln 2 over 2. I'm using a calculator. You can sue me, Cook, if you don't like that. I already looked at the book too, so I don't know why you would care, but... Oh my god! ln 2 is 0.69. Dr. L will be ashamed if he could see this. That I didn't know that ln 2 is 0.69. Wow. Okay. So which one heats up faster? Which configuration heats the resistor faster? The one with more resistance should heat faster. So I think the radial configuration heats faster. Okay. Now part F. Right. Oh no. Am I sure? It has more resistance. Doesn't more resistance mean heating faster? Or does it only depend on the resistivity? If the resistance is fixed, does the resistivity... Does it? I feel like it does. Doesn't more resistance mean more heat? Okay, we need to think about this. We need to consider power? Does it get squared? Is that the issue? Oh no, it's v squared over r? Or I squared r? The higher resistor has... What? What's the voltage? Is constant. So we want v squared over r, that formula? That's annoying. Why it should be as simple as more resistance means more heat, I feel like. Well, I don't know. Okay, but like, what is this power literally like heat or like I don't know. For the same resistance, more resistance means less current. I thought it's because the current is physically getting slowed down because it's generating heat. Like that's how resistance works. Uh, more power is more heat. I guess that also makes sense. Okay, fine. This is annoying. I think I don't know. I don't have a good enough intuitive understanding of like what is actually happening when a current flows through a circuit, and that's why I didn't realize that. I don't know. Okay, fine. Well, that's terrible handwriting. You suck at the concept of work in physics. It is really hard. Voltage times number of charges that pass is energy. Okay, Teratar. That's a good way of thinking about it. Because there's a higher current with less resistance. Suppose we can construct this resistor geometry for variable A. If we want the resistor to heat at the same rate when connected to a battery in the axial versus radial configurations, what value of A should we choose? The equal heating condition we mathematically express as transcendental equation in dimensionless variable x is defined as A over L. So this equation will require numerical solvers such as Wolfram alpha. Right, there we go. Hey, Chaotic Dude, for part E, the answer is the axial configuration generates more heat because it has more current flowing through it, basically. the less resistance actually helps. That I always think of resistors as like generating heat, and so I guess it's naturally I think more resistance means more heat, but I guess it's the opposite. The larger resistor will heat up faster. Okay, so I'm kind of right. Or, well, not really right, but there's that. Hey, Suna. Thank you very much. Welcome in, everyone. How's it going, Suna? Thank you very much. How's your stream? We're doing a physics problem from Dr. Cook right now. We're on part F. Here, I'll scroll up and show the original part of the problem here too. Pretty well, that's good to hear. Didn't die on power today? Oh, hey, that's good news. Can't complain, yeah. Okay, so we want to find what if okay, in one ring we can vary. Oh my god. So we want to make the radial configuration match the axial configuration. So we want to find okay, copy. Come down here. F. Okay. Now these A's aren't the same. This A over here is something we want to vary, but this A over here is just fixed. So should we make a B? Or maybe we should take the hint's advice and take X equal to A over L as well. They're the same A. Really? Oh, never mind. Okay. I thought we were going to have two different rings. That's what I was imagining. With two different dimensions. But we want to find the magical A where they do happen to be the same. For the same one. I don't know why my brain went to having two different things. Okay. Thanks for the lurk, Suna. Okay, so then if they are the same A, then we just want to equate these things and start going at it. We can take the hint's advice and define X to be A over L. Do we want to do that now or later? I don't know. Just start writing things out. Okay, and so what, we can get rid of the rows, we can get rid of the pies. Get L squared over 2AL plus A squared equals ln 1 plus A over L. And so now maybe the time is ripe to take X equals A over L. What happens here? The left side is just y and... Like, will the A's cancel if I just get rid of all the L's? I guess I can hope for that. Oh, they do cancel. Good. And this is what we would need Wolfram Alpha to save us from. X squared over 2x plus 1 equals ln 1 plus x. Not even Wolfram Alpha wants to solve this problem. There we go. Ooh. Well, we don't care about a negative or a 0 solution. So we just want the positive 3.4. About meters. Algebra error? Well, that wouldn't surprise me. Oh my god. What if I told you that A is not equal... Wait, what am I doing? I don't even know what kind of stuff I did. Let's just get rid of this. What was I trying to do? I was trying to get rid of the L's. So I should have said that L is equal to A over X. That's what I was trying to do in my head, and I thought I was smart enough to do that. Evidently, I'm not. So the A's can cancel. This is the one that we need to solve. Yeah, I think that's okay now. Hell if I know. 1 over 2x plus x squared. $69? That has to be intentional, right? I lost a factor of 2? Oh no. I did! I canceled that 2 and that 2. Oh my god. No, I didn't. I didn't do that. I just dropped that 2 entirely. Does that solve all my issues in life? Maybe? We don't get 69 anymore. 9-8. Alright. I preferred it when the answer was 69. But I might still be, I wouldn't be surprised if I still am doing something wrong, but. Oh, yeah, we need a value of A, don't we? That's a good point. Well, Timo Prom, thank you for the follow. So 0.98 times L. X is dimensionless. Oh. Okay, yeah, you're right. That makes sense. Ugh. So apparently it's this one. I'll put the meters over there then. That's the answer? Okay. That's a pretty neat question. Any feedback on sorry, change L to be B everywhere to avoid that further confusion? Oh, I mean, even then, I feel like I should have just known that. Like, I really knew to like ask myself that, and I just came to the wrong conclusion. But I mean, changing to B definitely doesn't hurt. Let's see. Requires almost A equals L, but not exactly. Yeah. Hmm. I honestly, I just want to leave it like I think it's a cool problem, but I don't know how much more I have to say because the only other thing I got kind of tripped up on it was interpreting what part F meant. But I'm also just stupid and not experienced with and I'm not experienced with physics problems, which are two things against me. um. Like I don't know how else I would phrase that to get the point across. So I assume it's just a me problem. I mean, I'm trying to think of like how I would rephrase it to avoid that, but I don't really know of a way. I think I just it's just a geometry for a variable A. If you no, I mean I don't know a way to make it clearer. I guess so. I guess when I was imagining like I was imagining like you have one like I would probably when I initially saw it, I interpreted it as like we have this resistor as a given, and then separately we have a different resistor that we've magically engineered to be variable in that like a dimension there, and like trying to make those match for the different like and this one is radial whereas the other one is axial, but that's where my brain went at first. But I guess it was the term like variable A that like threw me off there, but it is just a variable A, just not in the sense that I was thinking. Doing precedence of F help. Does it hit the same rate connected to? It might. Or like, I guess you could say like, suppose we can vary A as we please or something like that. But so we might still think we're taking A equals L. I guess so. Oh wait, this is the song. Oh, it's already at the end too. I only just now noticed. That wouldn't hurt for E, I guess. But honestly, like I feel like I've had a similar confusion about like Morn's problems too. Like it's not. I have a hard time saying if it's actually me or if it's, or I'm usually first to assume that it's me rather than the wording of the question. What time is it? Okay. I mean, I guess you could also say like I don't know. The first answer probably is just fine, but like I guess you could say like for a fixed L in the variable A, if we want the resistor to heat, you know, dot dot dot. I guess you could say that too as an alternative, but I don't know. It's probably just fine the way it is. Hey, Prakar. Oh, I'm definitely not a JE aspirant, but they do tend to be around here. Yeah, sounds good, Cook. Okay, Tinok, if you're still here, thank you for your patience. Let me find your problem. You said you posted it. Um, ooh, got a history type of problem? You are still here. All right. Thank you very much for your patience there. I know it was a little bit of a long problem, but uh, yeah, we're here now. All right. So what's happening here? That Cleomedes gives a simplified account of the work of Eratosthenes. The ancient Greek Eratosthenes. Yeah, no worries, Cook. Happy to do it. Like I definitely feel like I learned something from that problem. So, thank you as well. The ancient Greek Eratosthenes read a scroll that noted on the solstice in the city of Syene, an obelisk would not cast a shadow at noon. Oh, is this going to be the radius of the Earth calculation? Eratosthenes waited until the solstice and noticed that an obelisk created a shadow of 7 degrees and 12 minutes at their home in Alexandria. Eratosthenes paid a bemetis. People are trained to measure distance by controlled walking. Oh, I didn't know it was a profession. I thought he had like an unpaid intern do that. To walk from Syene and measure the distance. A bemetis found the distance between the two cities approximately 5,000 stadia. In reality, Eratosthenes connected several survey trips to measure the size of the Egyptian lands held by ancient Greeks, organize the size and shape of the Earth, creating maps based on this information in 184 BCE. Most of the original work has been lost due to the multiple burning of scrolls at the Library of Alexandria over time. Assuming the Earth is spherical and the two cities lie on the same meridian, not true, but will work for this simplification. Use the angle of the shadow and the fact that one stadia is equal to 157.5 meters. Calculate the circumference of the Earth, and compare that to the modern accepted circumference of the Earth of 40,000 kilometers. Note the kilometer is designed by SI to be 1/10,000th of the distance from the North Pole to the equator. Okay. This is a cool problem. So which one is the more northern city? Well, I guess the one where there's no shadow is the more northern city. So Syene, if there's no shadow at noon, that means it's basically on the equator, right? Because it's basically pointing right at the sun. Actually, well, that doesn't mean... It probably doesn't matter if it's northern or southern, just that one casts a shadow and one doesn't. All right, let's see. I actually haven't done this calculation for myself here, but I've heard of it and I know that it's a thing. Just the radius, or sorry, the circumference of the Earth, as Eratosthenes did it. Carl Sagan did this question. Oh, really? It's kind of sick. It's all there. Victicom, thank you for the follow. Okay, so I think what's basically happening is... Yeah, Cook. Just like, I feel like it's not actually saying all that much, but just his enthusiasm cracks me up. It's all there! Let's try and draw what's happening here. So I'm intending this to, not the sin, the sun. The one that's head on should be Syene. I'm probably saying it wrong, but... Timopron. Yeah, I learned about this problem. They didn't make us do it ourselves, though. That distance there is 5,000 stadia. Now, what angle is that 7 degrees and 12 minutes? It generates a shadow. Okay, wait. You have an obelisk. The sun is up here. That angle there is your 7 degrees and 12 minutes, right? And so that means, like, we're going a little bit past the triangle, aren't we? Or is it close enough that we could just call this angle the 7 degrees and 12 minutes? Or like, can we just do like that type of thing? Yeah, you think so? It sounds reasonable to me. If there's a difference, it should be pretty negligible. Oh, is that the Carl Sagan doing that? Um, how do we want to go about this? Now, I assume we don't want to approximate this thing as a right triangle. That's kind of against the spirit of the problem. But we could complete the right triangle if we do that. How do we figure out like what portion of the entire Earth this thing is? I mean, that's the problem, obviously. Do we work out like what this angle over here must be, and know that the entire thing should be 180 degrees? You're saying why not treat that as a right angle? I mean, it probably makes. I don't know how else you do the problem, I guess. Because I don't know how you do it if you aren't able to say that's approximately a right triangle. I guess so. So do we want to work out the rays coming from the sun are parallel? Really? Is my drawing wrong? I guess they'd essentially be parallel for a distance like this. We might. I might just want to look this up. Because I was kind of figuring, want to figure out. Oh, treat the Sagan video as a hint. Okay. If it's not too long, well, or at least I'll skim through it or something, I guess. But if it's something long, I'm not gonna. 6 minutes. Sorry, YouTube won't be able to hear this. Oh, hey. I was just thinking it feels kind of criminal to put Carl Sagan on quick speed, but he does talk slow. That's kind of a neat demonstration. Show it's still flat earther. Oh, okay. So the real thing, if this is the Earth that's flawlessly drawn, I'm just gonna pretend like our points of interest are up here. Well, I guess one is on the equator, we're gonna call it. One will put a little bit more north. That is the one that's head on. This one is the one that makes an angle of 7 degrees, 12 minutes, not drawn to scale. The point is that if you continue these all the way to the center of the Earth, that angle between them should be the same thing. And you know the arc length is 5,000 stadia. So do we want to get the... I mean, you used to get the radius of the Earth, couldn't you? And from there, get the circumference? Oh, there's probably a more direct way of doing it. Which is to multiply... I think you could take 5,000 stadia. Or, I mean, we can use the meter conversion too, but who cares? And I think we want to multiply by 360 degrees. That represents the total. Like, I'm treating this as like a proportion, I guess. I bet that will get us the right answer, where we know an entire circle is 360 degrees. Who cares what units we use? I mean, it's funny because for E and M, I guess you do have to care because the formulas look different, but yeah, I was thinking about that chaotic dude. I kind of see if they get the same result, but yeah, I like we could also figure that the radius of the Earth. Sorry, no. That arc length is equal to radius times well, in degrees, theta degrees over 360, right? And so you could... Oh, wait. Is this the radius of the Earth that I just got? Apparently it is. Okay. So, Tinok, I will look up and explain this, but I'm trying to, like, fumble my way through it first, and then I'll, like, come back and try and explain it in a more reasonable way. One stadia is 157.5 meters. But let's just do that conversion. Stadia times 157.5 meters in 1 stadia. The units cancel. That's a job for a calculator. 157.5 times 5,000. 787,500. Meters. Okay. So we can figure out the radius of the Earth using the formula for arc length is the point. Because we know S is this arc length here, so 787,500 is equal to r times the angle, 7 degrees and 12 minutes, divided by 360 degrees. Let's plug that into a calculator. Hey, Anders. 7 degrees, 12 minutes over 360 degrees. Let's hope Wolfram Alpha knows what to do with this. So I need to look up how to use minutes and seconds, because I honestly have no clue. 0.02. $787,500 equals 0.02 r. Now just divide each side by 0.02. So 787 divided by 0.02. $787,500 over 0.02. Oh, we're switching to scientific notation. That's not. I'm gonna keep it as not. 39375. Wait. And 3 zeros. 39375. 39375. 39375. 39375. 3 zeros. 39 million meters? 30 seconds of delay? Oh no. And then they want the circumference of the Earth. So we're going to do circumference is 2 pi times the radius. 39375,000. So we're going to take the same thing multiplied by 2 pi. Okay, now I will use scientific notation. 2.474 times 10 to the 8. Meters. Scary Halloween mask, you should have a jump scare warning in your title. True, hard locked. Ugh. It's really good, right? You wouldn't believe that someone actually has this face. Wait, 40,000 kilometers. What is this in kilometers? Aren't I way off? If you go from meters to kilometers, you take 3 off the exponent. And that's 247,400. That's way off. Oh my god. Did I do something wrong? That's not good. Wait. My answer for the radius of the Earth is really close to 40,000 kilometers. Why am I... Why is this wrong? Or what am I doing wrong? Am I getting the formula for arc length wrong? thought it's angle in degrees divided by 360. Yeah, I guess, does it not work at all in radians? Oh, if you do it like that. Two pi r theta over 360. Okay, well, that's just a and that's just circumference. Okay, so I did misremember the formula. So yeah, you can definitely convert it to radians and do it that way. If you want to keep it in degrees, it's arc length is equal to circumference times theta degrees over 360 degrees. That's what I should have said. So I actually did solve for the circumference in this first thing. And this was just garbage. And that's in meters, what I got here. And so you can convert it to kilometers. 39375 kilometers is the circumference of the Earth, which is pretty dang close. Okay, Tinok, I'm sorry for that terrible explanation. The moral of the story is that with the way the geometry works, I guess you can continue, like, if you start from the cities and go to the center of the Earth, those lines will make an angle of 7 degrees and 12 minutes with each other. And now you have a situation where you know the angle and you know the arc length, and you use that to work out the overall circumference. And actually, if you already understand this, then don't mind me, and I'll just like let me know, and I won't bother explaining it. But if there's a part that you're confused on, then let me know. In the meantime, I'm just gonna keep on explaining it. But Eratosthenes, yeah, that's pretty dang close. So you can use this weird formula that I found, but if you want to be safe, you could convert this thing into radians. 7 degrees, 12 arc minutes, 2 radians. Radians. Pi over 25. And so you could have done S equals R theta if theta's in radians, and set that. Actually, we want to work in kilometers, so I may as well have done that in kilometers. Equal to radius times pi over 25. Work out what the radius must be, and then you can get the circumference as being 2 pi times that. That can't be right. Yes, it can be right, actually. No, it can't be. Yes, it can. I'm trying to do some mental math on that. It's 50 times 787.5. Is that the same thing? It is the same thing. It can be right. Who would have thunk? So yeah, I guess this right here is the solution in radians, and this over here is the solution if you want to stick to degrees. The radians is probably, if you're comfortable with the conversion, I guess the radians is probably simpler. That's a neat problem. Where there's like a historical math problem, though, I always get tripped up by them. Like I took history math class, and they were similarly kind of tricky. Okay. Unless I see anything more from you, I'll probably move on to a different problem. Thank you for the question there, Tinok. Oh, what time is it? Okay. I do have to tutor someone tonight. I also scheduled it not remembering that it was Halloween, so I hope they're still around, but I don't have that much longer that I'm going to want to stream for. I can go for a bit longer, though. Should note, just delete the page. Don't need it. Delete. Keep. Okay. My old arch nemesis. What I wrote on green isn't true. I can get rid of so many of these tabs. Oh my god. That's just, oh, okay. Let's look at that. I, I think I know what the formula for H should be, I think, but I'm trying to justify it in my head. Or I'm trying to actually, like, not in my head, just like justify it. So I'm looking at what H should be in each of the quadrants and hoping that'll lead me to some conclusion. Welcome back from the shadow, Suna. Whirling Clouds, happy Halloween to you too. Can I work without just... Okay, you know what? Can we be more intuitive about how this thing should act? Just get rid of all this. Burn it. Oh no, I'm not going trick-or-treating. I'm hiding inside. I'm not super into Halloween. How about you, though? Sun laser to the fire? Yeah. All right, so I'm kind of cheating here because I know I'm like 99% sure this is what the solution said H should be. But if I can at least justify it, I'm happy with that. So when theta equals 0, no, this doesn't make sense. Well, how are you, what we're defining is 0H. This doesn't make sense at all. Is this what the solution said it should be? This doesn't feel right. Maybe, oh, wait. If I define the 0 to be down here, I think maybe it does make sense. Because when theta equals 0, the vertical displacement is just r. So that tracks. If theta equals pi over 2, the 0 is a bit of an issue. Do we want plus? Is that what? Did I misremember? Because we should have 2r displacement there. If theta equals pi, we have just r, that's good. If theta equals 3 pi over 2, we have 0, so that's good. So maybe it is r plus r sine theta. Without checking any other angles. Theta equals just like pi over 4 or something. Yeah, that makes sense, I think. Okay, I think I'm happy with h equals r plus r sine theta. Yeah, Phobos. I attempted it. Wait, where is it? Oh, I deleted it. It is my white whale. Okay, I deleted my other attempt, but I rewrote this thing a couple times. I did a completely separate attempt down where this thing is now, and I'm tearing the entire thing down, doing a different construction that matches the solution keys. I've skimmed the solution key, and I saw that they defined their theta measure from the horizontal like this, so I'm going to try and do it the same way. But I think otherwise my approach hopefully will work. I don't know. It'll at least be easier to check. But like the problem is so annoying. Thank you for believing in me. What am I doing here? Tangential acceleration. That's v squared over r. No, is that? I need to remember my formulas. No, radial is v squared over r. Tangential. Yeah, okay, I guess that makes sense. So what is tangential? What's the spookiest geometry fact you know? Cosmolano asks. That's a good one. Honestly, okay, this is, I feel like most people are gonna think this is mundane. But how the hell do you have something with an irrational length? Like it just like how would you ever like measure that like physically? that always like trips me out. I don't know. Like just the idea that a length can be irrational just really disturbs me. And if you want something even spookier, I'm gonna have to look at whatever theorems they use in competition geometry. Like if you did have somehow have a length that was irrational, like I think you could never prove it, right? Because how would you measure that exactly? Yeah. So I don't know, that spooks me out. Dude, I'm so terrible at flipping my pen. Yeah, to be honest, I've been working on this one for way too long. The spooky action at a distance mathematically. Spooky action at a distance? And dot it with J cap. I forgot you were like doing that J cap thing that I don't quite get. What? Oh, okay. So it's just a thing I haven't heard of. Spooky action at a distance. Quantum entanglement. Um. 2g r plus r sine theta over r hat plus. And now how did I work out what did I do up here? It was just g sine theta. Do I want the same thing here? Probably not. How did I work that out? I was cooking something up there. Here, like at this exact point, the tangential acceleration is pointing that way. So that makes a right angle there. Maybe I don't want that right angle. Maybe I want this right triangle? No? What do I want? Or more so how quantum measurement and entanglement work together to make things appear to travel faster than light. I like barely scratched the surface, stuff like that. I'm still very struggling with my mechanics, but yeah. I believe it for what it's worth. Right, so in Cartesian coordinates, the acceleration, I mean, the total acceleration, I mean, regardless of coordinates, the total acceleration is just pointing straight down all the time, right? But we're breaking it up into radial and tangential. How does that geometry work? How does any geometry work? Okay. Can we make the claim that angle here is also theta? Because this angle here is pi over 2 minus theta. And the other one should be pi over 2 minus pi over 2 minus theta. And so we would want cosine of that theta. I think that's the weird justification that I'm probably supposed to use. Are you setting the y component centripetal and weight equal to 0? The sum of them. Eventually I'm going to take the y component and set it equal to 0 here. But I think you have to work it out in this radial and tangential component first, and then convert it to Cartesian. Right, so that's how I'm trying to approach this. Ultimate entanglement is necessary. Yeah, no, I've heard that that's a thing that people hype up as being possible, but it's just not actually possible. I wouldn't know the first thing about it either way, though, personally. Oh, the R's can cancel from my radial component, can't they? Okay, let's chase this rabbit all the way down its hole and see what we get. The last time I was running this problem, I kept getting cosine plus 1 squared equals 0 or something like that, and it was no good. So r hat is cosine theta I hat plus sine theta j hat. Now g cosine theta minus sine theta I hat plus cosine theta j hat. Okay, now let's group the i's and j's. Okay, 2g 1 plus sine theta cosine theta minus g sine theta cosine theta I hat plus 2g 1 plus sine theta plus g cosine squared theta j hat. All right, now let's take the j, set it equal to 0. 1 plus, what am I writing? Sine theta plus g cosine squared theta equals 0. Why did I put that parentheses there? We'll never know. Okay, what's happening here? The g's go away. 2 sine squared theta 1 minus sine squared theta. Please tell me we're not getting garbage here. I would be really sad if we're getting garbage answers here. I think we're getting garbage answers. Fuck me. This is the same exact type of answer I was getting last time. It's not going to be theta equals 3 pi over 2, unfortunately. This isn't right. That's not what the answer should be. Is centripetal xy times v squared over x squared plus y squared correct? I haven't seen that before. Or with a minus in front. I haven't seen it before, at least, Teratar. This is so annoying. Vector always points towards the center of the circle is what you're thinking. That's why the minus x and y are there. Unit vector times magnitude. Maybe? Honestly, okay. I already looked at the solution for this once. I'm gonna try and take a peek. Not at the entire thing, but at least a part of it, because I'm so I just want to get to the bottom of this. My formula for h is wrong. As it falls from the top? Okay. So I was taking my 0. Oh, yeah, okay, that's smart, Fembox. Yeah, I was taking h as the bottom of the circle. But that doesn't make any sense. That's backwards. Okay. If we want this thing, can we just slap a cosine on it? Would that solve all our issues? I don't think it would. No. If we do a minus, though, it would. So was I remembering right? I was remembering when I did look at the answer key that it was r minus r sine theta. I thought I misremembered. What does this get us? So if we're measuring 0 height as from the top, for the sake of h, how is this thing? If theta equals 0, we get just r. That's good. If theta equals pi over 2, we get 0. That's good. If theta equals pi, we get r, which is good. If theta equals 3 pi over 2, we get 2r, which is good. Okay. Let's make that change. That's not what I wanted to delete. That's what I wanted to delete. That's not what I wanted to delete. That's what I wanted to delete. There. 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 And now this will just get rid of. Maybe Territor. I feel like that might also be right, but I'm already like, oh, what did I delete? Okay, yeah, I need to also delete this one over here. I think the way that I'm doing is more in line with how the book was doing it, and I'm trying not to get too crazy and reinventing the wheel right now. Oh, wait. Oh, I might be happy now. This might actually factor into something that isn't garbage. Hey, Pungalis. Yeah. just working on this physics studying problem that has been plaguing my life. Okay, that's how it factors. Okay, we get sine theta is minus a third. That's good. Sine theta is 1. That's garbage. I assume we just want the one on the left. Okay, what is... That's not unit circle, right? So give me sine theta equals a third, Wolfram. Show me theta. Okay, give me the helpful version, Wolfram. I want you to do the arc sine. Ugh. $19.47 degrees. Um, 19.47 degrees plus 360 degrees. 379.47. That's one of our answers. I forget. 379.5 degrees. And there's another one. 379.5. We want to subtract off 90? Is that what we want to do? Not necessarily, right? We're in quadrant 4. We want to get to quadrant 3. What do we subtract? I'm not good at it when it's not unit circle, I guess. What will Wolfram Alpha do for me? For the other solution? I have to go back to the original arc sine. Yeah, I wanted the two positive ones, I guess. I think we want to do pi minus 19.47 to get this one, and then add 360. Yeah. So 180 minus 19.5 plus 360. That's not right. That's not right. No, we don't want to do that. Doing just 180 minus 19.5 is okay. 160? Is that reasonable? That's negative 160. $360 minus 19.5? No, maybe? I don't know. It should be negative plus 360. 199.5? I think that's my answer. I don't know if it's the answer, but I think that's the answer that I wanted. Wait, they're measuring theta going down. I did get... Okay, no, this is the right answer. I'm measuring theta the opposite way, though. Wait, am I even right? 19. I'm 160.5. 160.5. I think I'm right. It's just like getting them to match is the weird part. I didn't realize they're measuring theta clockwise. Who measures theta clockwise? That's so random. Oh my god. That was so much simpler than... Oh my... Okay, you know what? God fucking damn it. I made it so much harder than it had to be. Okay. Yeah, if I just thought harder about the components of the radial and tangential accelerations, I would have done it. And yeah, there's our... I mentioned to like see more about like how you're trying it, but I just like... I feel like doing an entire like other leap than what I was already like doing, I guess. Okay. I think I need to call it, guys. It seems easy. I'm sorry, not to me, but I'm also stupid, so... Alright. I was about to wrap it up, Master of the Game, but if you can type your question out, if you're just doing a derivative, I can probably do that. What comes after chain rule? Oh, you're just like asking like in general what's going to come next? It depends exactly how the class is being taught. I can let you explore a bit on your own, or I can try to tell you too, but let me... This is my favorite website for everything calculus. And so actually let me... If you go into the sidebar, and then expand the section for Calc 1, you're going to be living like right here in section 3 for derivatives. And so you can even just like look around here and see like, don't just look at chain rule, look down, but like look up to and see if you've missed any of this. But I would just look in this like sidebar here to see what comes next. Paul forever, yep. So I'll drop the link there. It's like implicit differentiation, related rates. Like I think if you know like product rule, quotient rule, trig functions, exponentials, all that stuff. The hyperbolic function you can probably skip, by the way. Probably in most classes you don't need that. So if you haven't seen this before, don't worry about them. But yeah, normally chain rule is the last thing you learn before you start applying it. Or at least like you learn about some other like, they're not quite as like direct formulas to memorize, like product and quotient rule. So like implicit differentiation, related rates, higher order derivatives, like these things are I would probably look at the most for you. But yeah. Thanks for hopping in, Master of the Game. How's this made? How is what made? The website? I don't know. I technically have made a website before. As part of a class, but you don't want me to tell you how to make a website, I don't think. All right. So yeah, I'm gonna cut the YouTube stream off here. So Master of the Game, Teratar, anyone else who's here on YouTube, thank you all. I'll be back on YouTube on Saturday.